So today we'll be taking some notes on your own in your notebook, all that fun stuff. It's kind of a continuation of yesterday's class, which is great. And then tomorrow, talk tomorrow. Tomorrow you'll have a formative. Short. I think I made it 6 questions. So not very long. Plenty of time to do it. After the formative tomorrow, you'll be getting the review packet for sections 4.2 and 4.3. And then we'll do some reviewing tomorrow. More review on Friday. Summative test on Tuesday. Okay? On Tuesday, it'll be a 2-parter test, non-calculator, calculator part. Okay? And then we will allow you to use the identities sheet. For you, it's pink. And it's a pink full sheet of paper that you got. However, on Tuesday, it will not be pink. It'll be cream, and it'll only be a half sheet. We'll supply it. It's the exact same thing as your identity sheet. It just doesn't have any extra notes or your name on it. Okay? So, just so you know, we'll allow you to use that on it. We will be covering up the unit circles that day. So you need to remember the unit circle again. That's why we had you memorize it. Okay? So if you haven't practiced making your unit circle in a while, at least memorize quadrant 1 of your unit circle. Okay? Okay? And then I want to take just a couple of quick seconds here to talk about homework. So those 6 homeworks are going to be collected on Tuesday. Now, we have the rule of 83. Okay? So if you're getting better than, so we set the bar at 83. Now, why did we choose 83? Because we didn't like 80 or we didn't like 85. You know what I mean? So we put it at 83. I just randomly shouted out a number and we went with it. Okay? All right? So if you're below an 83% right now, okay, you have to do those 6 homeworks. Great practice. Awesome. Turn them in. They're due for you on Tuesday. Okay? That's the easy part. Above, now is where the hassle comes in. Okay? It's not really a hassle. Hassle is a bad word. Confusion, I think, is a better word. Okay? So if you're above an 83%, you still have to do those 6 worksheets. Okay? Because they're great practice. They're what your test is going to be like. That's why you should still do that. Okay? You just have the option of, do I want to turn them in? If you say no, fine. It's not going to hurt you. It's going to go as an X in the grade book. If you say, yeah, I did all this work, I want to get some credit for it, and you turn them in, I'll grade them like normal, or we'll grade them like normal, and then they'll go in the grade book like normal, and you'll either get points for them, or you'll have to go back and fix them and then get all your full 100% points for them. Okay? You have that option. You can take that out. Still got to do them. You just don't have to turn them in. You have the option of turning them in and them being great. Okay? All right? So, with that being said, what I would like you to do for these 4 is, I would like you to, 1, find me the reference angle for each of those 4. And then 2, find me a positive and a negative coterminal angle to go along with all of those 4. Okay? If it's in degrees, your answer can stay in degrees. If it's in radians, your answers, because there's going to be 3 for each one, your answers should be in radians. All right, so 150 degrees be over here in quadrant number 2. So there is my 150 degrees, which would put my reference angle right there. So my reference angle would be 30 degrees. Reference angles get you back to the horizontal. So it takes 30 degrees to get back to the horizontal on that one. Some positive coterminal angles I'm going to add, and that's kind of why I do always put a positive like that, because I'm adding 360 degrees and I get more. So that's 510 degrees. That's 870 degrees, and that's 1230 degrees. Okay? If I'm getting the negative ones, I'm going to subtract 360 degrees. So that would be like negative 210, negative 570, negative 930 degrees. You would only need one of those, but I gave you three options. Okay? Negative 370 degrees is actually down here, because you come all the way around plus some, and then that puts my reference angle up in there. To get back to the horizontal, my reference angle would be 10 degrees. Okay. A positive degree measure would be like 350 degrees, 710 degrees, 1070 degrees. A negative, we could have negative 10 degrees, then we'd have negative 370, then we'd have negative 730, then we'd have negative 1090 degrees. Okay. 3 pi over 11, that one's kind of the goofy one here now. 3 pi over 11 has, let me get my, so this would be 0, this would be pi, or in terms of 11ths, that would be 11 pi over 11. Which means that straight up would be halfway, so that would be 5.5 pi over 11, which means that 3 pi over 11 is going to be somewhere here in quadrant number 1. So it's its own reference angle, so the reference angle to get back would be the same here in quadrant 1. Now, to find other positive coterminal angles, I just need to keep adding 2 pi. But I'm not really going to be adding 2 pi. I'm going to add 22 pi over 11. So I'm just going to add 22 to the numerator. So my first one would be 25 pi over 11, then 47 pi over 11, then 69 pi over 11. Because you add the 22 pi over 11. Subtracting the 22 pi over 11 then, you would have negative 19 pi over 11, negative 41 pi over 11, and negative 63 pi over 11. Negative 9 pi over 7. So this would be, I did it in purple, this would be 0. This would be negative pi, which would be negative 7 pi over 7, if we come all the way around there, which would put me then up in here, because this would be negative 10.5 pi over 7 this time. So that would put me up in here. So this would be my theta all the way around to there. So my reference angle then would be 2 pi over 7. Takes me back down to the horizontal. 14 is my magic number. Fourteen is my magic number. and we get those. Agree? So this slide you got yesterday at the end. It was the last slide we took notes on yesterday. So if you have it written down, great. If you didn't get it written down because you had to leave early or something like that, start scribbling. Okay? So in general, if our angle goes through a specific point, okay, and it's in standard form, or excuse me, standard position, R then is going to be the hypotenuse of the right triangle that we made. So, or R is the distance from the origin to the point. So that's always going to be the square root of x squared plus y squared. Okay? So if that's the case, then the sine of theta is always going to be y over r. The cosine of theta is always going to be x over r, and the tangent of theta is always going to be y over x. Okay? The other three, you got it already. The other three are just reciprocals of those. So cosecant goes with sine, so it's r over y. Secant goes with cosine, so it's r over x. And cotangent goes with cosine, or it goes with tangent, and it's x over y. Okay? So we have that. Then we say we can find the reference angle by finding the inverse tangent of y over x. And we drop the negative sign because then that puts us into quadrant 1. Gives us an acute angle in quadrant 1 if we drop the negative signs. From that then, from our reference angle, then we can determine actual theta based off of what quadrant we're in. If we're in quadrant number 1, it's the same. If we're in quadrant number 2, we subtract our reference angle from pi or 180. If we're in quadrant 3, we add 180 or we add pi to it. If we're in quadrant 4, we subtract our reference angle from 360 or 2 pi. Okay? So we have all of those. Now, where we're going with that is we started a couple of these yesterday, so we're going to continue on with those today. Here is, we are asked to find the cosine, the tangent, and the actual theta if we have the certain conditions. Now, I will tell you this, that if I just gave you this, would you be able to find theta? Yay or nay on finding actual theta based off of this? Why nay? Oh, I'd ask you. I'd still ask you. But it is nay. Why is it nay? Because sine is positive in 2 quadrants, right? But theta is only going to be in one specific theta. And so if we just have this, sine is positive in quadrants 1 and 2, top half of the unit circle. So we can't do that. So we have to give a second condition. Okay? And so the first thing that you should do is you should figure out which quadrant your theta is in. So if I'm looking here at sine, sine is positive in quadrant 1 and quadrant 2. Okay? Where is secant positive? 1 and 3. Do we agree with 1 and 3 for secant? Secant is x. It's with cosine. So it's not right. No. It's 1 and 4? It is 1 and 4. Okay? So based off of that, which quadrant am I in? I'm in quadrant number 1, right? Okay. So what I'm going to do then, and you don't have to necessarily do this, but trust me, it helps. I'm going to draw myself a quadrant 1 right triangle. From that right triangle, I know that this is my theta. It is also my reference angle. Both, because we're in quadrant 1. If the directions or the problem said that the sine of theta was 3/5, so that means the sine is the opposite over the hypotenuse. What's my missing side? 4. Okay? If you haven't memorized 3, 4, 5 as a right triangle Pythagorean triple, you've got some memorization to do. Okay? 3, 4, 5, and its multiples. 5, 12, 13. Next step. Okay? So we got that. If it wasn't the Pythagorean triple, then we could use the Pythagorean theorem to find that missing side. Okay? So from that, then, we can say, well, now I can say what the cosine of theta is. What is the cosine of theta? 4/5. I can say what the tangent of theta is. 3/4. And now I just got to find my theta. So I'm going to use the fact that our reference angle is equal to the inverse tangent of y over x, or opposite over adjacent, 3/4. And when I do that, I get the fact that theta, my reference angle, is 36.86989765 degrees. Because I am in quadrant number 1, actual theta is equal to reference angle. So actual theta would be 36 let's call it 87 degrees, because I'm running out of the space. Okay? Questions on it? You now try this one. I don't know, you tell me. So secant is attached with cosine. It's positive, so that's quadrant 1, quadrant 4. Sine is negative in quadrant 3 and quadrant 4. So which quadrant is my angle in? Quadrant 4. Okay. So I'm going to draw, and you don't have to do this, but I just find it easier. I draw myself a quadrant 4 triangle. Secant is adjacent and hypotenuse, because it goes with cosine, which then means that we're going to have to run a little Pythagoras. Because we're in quadrant 4, I'm going to make it be negative, okay, because it should be negative. So then that tells me then that the cosine of actual theta, which, by the way, actual theta is here, theta prime is there, my reference angle is there. So actual cosine then would be 2/5, just the reciprocal of the secant. Cosecant of actual theta is going to be the hypotenuse, r, over the y value, negative square root of 21. So I actually like that. I like my negatives up top, not on the bottom. Put that negative up top, which is fine. We would accept that as an answer. But if you wanted to rationalize it to negative 5 square roots of 21 over 21, we would also accept that too. Then I just have to find actual theta. So I'm going to have to go a little theta prime. My reference angle is the inverse tangent of the square root of 21 over 2. Making sure that I am extra super duper careful when I type that in, because that should give me 66.421825152 degrees. If you didn't close the parentheses on your square root, you're not going to get that. Okay? And then because we are in quadrant 4, my actual theta is 360 degrees minus my reference angle. So then that's going to be that here. That one, 360 minus that one, 293.578178.5. We'll call it 293.58 degrees. Yeah, buddy? Yeah, buddy.